Now the fourth fundamental theorem for this course that we're going to go over is the Euclidean algorithm. That's whoops, I already messed up. Euclidean. Euclidean algorithm. And the Euclidean algorithm is a little tricky. It's more like a set of instructions used to find the greatest common denominator or divisor without factoring. So what it says is step one, divide the larger number by the smaller number to get R. So you're looking for the greatest common denominator, greatest common divisor, I'm not sure which one it is honestly, between A and B. So the first thing you're going to do is look for the large number, you divide the large number by the smaller number and you find the remainder. So step one, if A is larger than B, then let's say this is A, or let me use the right color. This is A and this is B. Then the remainder is what it takes to get B up to A. And you'll replace the larger number with the remainder. Okay, so this is like the whole thing in a nutshell. So I'll move that over here and then I'll write this out step by step. There's 3 steps. The first one is divide the large number by the smaller number to get R. And I'll write that. So let's use the keyboard. Divide the large number by the smaller number to get R. Alright, and we can change the color of R, at least most of it. Try not to turn the whole screen brown. That'll work. Okay. And R is the remainder. Divide the large number by the smaller number to get the remainder. Second, replace the large number by R. So you put R into there and then repeat until, so let me write this 2. What color should I use? Replace the large number by R. I'll write it down. Apparently not. Replace the large number, in this case A, by R. Alright, and we will do our best to change the color of A and the color of R. That seems to have worked. And finally, as most of the last stages are, repeat. Let's see if I can write it. Repeat until the greatest common denominator between, okay, what it will come down to is 0 and some remainder, R. So once your R is matched up with a 0, then you're done. And your answer, we'll get to that. Repeat until that equals. So we'll put a 3 here. Now, let's say we're looking for the greatest common denominator between greatest common divisor between 1170 and 924. Okay, so if we have 924, how much do we need to get to 1170? And that is 246. 246. So then you take 246 and you plug it in to replace the larger of the two. So this now becomes the greatest, and you repeat, greatest common denominator between 246 and 924. And 924 can be divided into 3. You get this times 3 plus 186. So the greatest common denominator, or divisor, I'm sorry, the remainder is 186, and you replace the 924 with that. So I'm just going to write R equals. Okay. This implies, that fixes everything. So now the greatest common denominator is between 246 and 186. So you do the same thing again. You say 186 plus 60 is the new remainder. The larger of the two gets replaced with 60. Now you rewrite it. Greatest common denominator between 60 and 186. What is the remainder? The remainder is, well, sorry, 60 times 3. If you go from 60 times 3 plus 6, because 60 times 3 is 180 and the remainder is 6. So this time the remainder is a very, very small number. Now, remember earlier there was a actually, I want to digress for a second. I want to go back to the division algorithm. That was the first of these 4. Now, the division algorithm is what we're using to find out our greatest common divisor. But there's something I forgot to write in, and that is that R is always between 0 and B. But it's never equal to B. And B needs to be in blue. And we see this down here when we're looking at the Euclidean algorithm. We start with 246. That was our first R. And then as B became smaller, it stayed between the smaller B and 0. So it became decreasing. 246, 186, 60, and then just 6. So once we get down here, we know we're very close to this being over. And the remainders never get bigger than the previous one. So if you have a remainder that's bigger, you made a mistake, you should back up and try again. Anyways, let me finish this. So we replace the larger of the two with the number 6. And now we rewrite it, greatest common divisor between 60 and 6. That is 10. So we say we have 6 times 10 with a remainder of 0. So now we're not done. I know it seems like it, but we replace the bigger number with 0, and now greatest common denominator between 0 and 6. Now we're done, because repeat until this. So what now? Well, the greatest common denominator divisor between 0 and 6 is 6. Which implies, actually, I'm going to make this arrow yellow because this is what the statement was trying to get at. It implies that the greatest common denominator between, and I don't know why all of my things are written now at angles, but between 1170 and what was our first one? Oh, 924 and 924 is 6. Yes, these numbers are so random that the highest common the highest common divisor between them is just the number 6. Anything after that, it doesn't fit. So that's how you determine the greatest common divisor between two numbers using the Euclidean algorithm. And that concludes this set of 4. We went over the Euclidean, the greatest common divisor, the fundamental theorem of arithmetic, and the elementary division algorithm. So that sums up this portion of the series, and I will continue on to make more. I will see you guys in the next set.